Welcome back, folks. Today we are going to look, oh, by the way, JLand Bio here. We're going to look at the concentration of solutions today. So we're going to look at how diluted or how concentrated solutions are and look at how chemists determine the concentration of solutions and ways that they calculate that. So hopefully by the end of this particular video, you'll be able to calculate and express the concentration of a solution in a variety of different ways. Only a few key vocab terms here. We're going to talk about the word concentration as it is in regard to chemistry. We'll also talk about molarity and molality, something you'll become very familiar with, especially if you take Chem 2 and AP Chem. So the concentration of a solution is the measure of the amount of solute in a given amount of solution. So I want you to think about Kool-Aid. If you have a dilute or weak concentration, then the Kool-Aid's not going to taste very good. It's going to taste very bland, mostly like water. If you have a very high concentrated solution, it means there's a lot of sugar, there's a lot of Kool-Aid molecules that are in there that are going to give it a lot of different flavor. So the higher the concentration, the more solute is dissolved in the solvent. There are several different ways that we can measure this as well. We'll talk about molarity, molality, and so on. The first one we're going to look at is molarity. And molarity is a very common way that we look at the concentration of a solution. Basically, it's the number of moles dissolved in every liter of solution. And so the formula for this is moles of solute divided by liters of solution. It's almost kind of like a density type formula. Molarity is given a unit of capital M that represents moles per liter. So I could give you moles, I could give you liters, I could give you grams, I could give you milliliters. There's lots of different ways that we can create and go through and calculate concentration problems. So let's take a look at our first problem here. It says calculate the molarity of a solution with 90 grams of sodium chloride dissolved in 2.50 liters. Well, this is pretty straightforward. Remember that our molarity formula is equal to moles over liters. Okay, so we are given liters. We need to calculate molarity, but we are not given moles. We are given grams. So as a result, we're going to have to do a little dimensional analysis to convert grams into moles. So let's start with that. So we're going to start with 90 grams and sodium chloride, NaCl. Grams goes on the bottom of the next step. We get moles on top of the last one. We need to do a little bit of calculation here. Let's figure out our molar mass of sodium chloride. Our molar mass for sodium chloride is 58.44. All right, so we're going to do some math here. Using correct significant figures, we have 1.54 moles of NaCl. So now that we have moles and we have liters, we just plug it into our formula and solve for molarity. So molarity is going to equal 1.54 moles over 2.50 liters. Do our math. Using correct significant figures, which we should have 3, we're going to have 0.616. And the way we write this, we write big M and NaCl. Okay, so that's how you determine the molarity of a solution. So keep in mind you may have to convert moles into grams or milliliters into liters. It's just going to depend on the type of problem we're looking at. Let's move on. So when we buy chemicals from chemical companies, a lot of times they're in very concentrated solutions, and a lot of times we don't want a bunch of 10th graders playing around with concentrated solutions, so we have to dilute them. There's a formula that we use to actually determine how we dilute a particular solution. It can be calculated by using the following. M1 times V1 equals M2 times V2, where M1 is the molarity and V1 is the volume of the initial solution, and M2 and V2 are the molarity and the volume respectively of the solution that we want in the end. So we can do some calculations to determine how much we need to dilute something by in order to get it into the concentration that we want. It's pretty straightforward. Let's take a look at a practice problem. This question reads, how many milliliters of a 6 molar solution would be needed to create a 100 ml sample of 0.05 molarity? Now again, lots of different ways we can give these types of problems, but I'm just going to give you an easy one to start off with. So what we want to know is how many milliliters, so we're looking for a volume, of this much of a solution, that's a molarity. We need to create this and this. So here, we were beginning at the beginning, so we've got V1 and M1, and this is going to be V2 and M2. We just need to make sure that our units on both sides of the equation are the same, so it's pretty straightforward. We've got milliliters and milliliters, and we have molarity and molarity, so we just plug our numbers in and solve. So in this instance, 6.0 M1 times V1, which is our unknown, equals 0.05 times our V2, which is 100. Okay? So we just need to isolate V1 by itself. So we're going to take 0.05 times 100, and we're going to divide that by 6. And the number of milliliters that we need, V1, using correct significant figures, so we're going to have 2 in our answer, is 0.83 milliliters. There you go. All right. Again, pretty straightforward on how to do those problems, but also keep in mind I may ask you to calculate the molarity of something or ask you to give me the volume in a different unit. So just keep those things in mind. One of the last units that we're going to talk about is known as molality, and molality is expressed in a little bit of a different way. It's expressed as the number of moles of solute per kilogram of solvent. So we're not looking at liters anymore, we're looking at kilograms. And we're also not looking at liters of solution, we're looking at kilograms of solvent. Again, same concept. We just need to make sure that we're looking very, very closely at what we're given in our problem and make sure that we calculate to get to the units we need to be able to solve for molality. Also keep in mind that molality is given by little m as opposed to big M. Just a couple little things to keep in mind. So here we're going to determine the molality of a solution that has 81.3 grams of C2H6O2, known as ethylene glycol, and it's dissolved in 166 grams of water. Well, again, the question is asking for molality. So we're going to use little m, and remember, that's moles over kilograms. So we're going to need to do a little bit of work here. We've got this is our solute. We're going to need to convert that to moles. And this is our solvent, and we need to convert that to kilograms. So we have two little problems that we're going to do here. Let's start with our mole problem. So we need to have 81.3 grams of C2H6O2. Okay. Grams to mole. So we're going to need to find the molar mass. Again, we find that on our periodic table. It gives us 62.08 grams for every mole. Do a calculation and solve. Using correct significant figures, we end up with 1.31 moles. Okay? That's our starting amount. We also need to know how many kilograms of solvent we have. So we're going to start with 166. We're going to start with 166 grams of water. And again, we need to do a molar mass. Remember, though, we're converting this to kilograms, not moles. I actually just made that mistake and had to edit it out of the video. Kind of embarrassing. Let's make embarrassing the word of the video, because I'm kind of embarrassed by the fact that I went through and did that. But anyways, when you get in the habit of doing something, yeah, you know. 1 kilogram for every 1,000 grams. So we do our math here. We're going to get 0.166 kilograms. And all we need to do is take our moles and divide by kilograms. So we're going to take 1.31 divided by 0.166. That's moles over kilograms. And we're going to get our molality, which remember is represented by a small m. Using correct significant figures, we're going to have 7.89 and little m, molal, that's kind of the shortened term for it, is molal, of C2H6O2. Right? That's how you go through and do those types of problems. So just take it one step at a time. Make sure you read each question very carefully. Again, RTFQ, right? Make sure you if you need to convert your units, make sure you do that as well. Pretty straightforward stuff. All right, so to make a long story short, the concentration of solutions is the amount of solute per unit of solution. We can use molarity and molality to calculate different types of concentration. So I'd expect you to be able to do that and do that fairly easily. All right, guys, this is the end of the video. I hope you have a great day. We will see you next time when we start talking about, I think, colligative properties of solutions. Sounds fancy? Because it is. We'll talk to you later, guys. Have a great day. Bye-bye.